Hello, everyone. Good morning, good afternoon, good evening, wherever you're joining us from today. Welcome to today's webinar on the topic of security for Kubernetes. We have Seth Mason joining us from D2IQ. He's a product manager at D2IQ. And then we also have Prabhu Subramanian from Shift Left, who's our lead architect, joining for the webinar today. Couple of reminders for the webinar. At any point you have questions, feel free to put them into the Q&A panel, and we will get to them at the end of the webinar. And we will also send out links and information as we mention them on the chat window. So please keep an eye on that as well. Today's webinar is recorded, so we'll also get a link after the webinar is done. And again, thanks for joining. Over to you, Seth.
Sure. Thanks, everyone. And welcome to today's webinar. We'll be talking about Dev and GitOps friendly security for your CI/CD pipeline. And so, as we talk to, some of our customers and the developer populations, we've noticed a big evolution in the skills that are required and the challenges that are facing developers today, especially as they make that transition to building applications to run on Kubernetes. Are they shifting from these big monolithic applications to microservices? And based on that, they're having to ship a tremendous amount more code and more builds. This therefore has a lot more surface area for vulnerabilities, attacks. And however, they still have the requirements of having to have solid testing, vulnerability scanning, licensing, as we see more and more people adopting significantly more open source software. And also, we're seeing a movement towards the amount of security scanning being done by developers. Prabhu, how would you see the threats from a surface area? Right? Do you see an increased amount of surface area? And what type of threats are you starting to see?
Absolutely, you were spot on. There is now an increase in surface area, also called as threat radius, and because of these modern architectures that heavily emphasize microservices and connecting the services using service mesh technologies and so on, there is opportunities for more and more insecure practices, human errors. So security is becoming more important as we migrate to cloud and cloud native architectures.
What are some of these insecure practices that you're starting to see?
On a broad scale, the OWASP top 10 categories that's been identified and practiced upon are continuing to be valid even on a cloud native architecture, right? These are insecure authentication authorization layers, default credentials being used, all the ports generously being open. Like we don't strictly practice zero trust model, isn't it? So we let all the services interact, work with each other. This is partly due to the nature of some of these advancements where there is big emphasis on moving to the cloud at a pace and sacrificing on aspects like security and other best practices. Also, security as a paradigm is evolving in a sense. We used to do security right at the end of the dev cycle, which is like all of the dev work complete, all of the functional tests, performance tests, everything being carried out. And then we did security tests in the form of reviews performed by top experts or penetration testing or a combination of these two. But with more and more microservices being developed, the amount of builds and deployments are kind of becoming increasing. So we have from bi-weekly builds to we are moving to a model where there are daily builds, and some organizations are doing even multiple deployments every day. So the need for security to be part of the DevOps workflow as left as possible becomes important. And at the same time, the security tools and processes should also understand not just the dev side of things, but also the far right, which is the containers and orchestrators and the cloud side of things. So the security is becoming like it's mentioned here. It has to move both towards the left, which is all the way to the IDE, all the way to the ideation process, as well as to the right, which is the containers and orchestrating and building and deployment of cloud native applications.
As things shift more towards the left of security, shifts more to the developer, how do you see the role of that centralized group changing, right? Which I'm assuming would have been like your traditional like InfoSec, centralized organization.
Absolutely. So this is where the need for DevSecOps becomes essential. DevSecOps is both the process, culture, and people, right? So it is no longer enough where we have people dedicatedly focused on dev and then people focused on ops and people focused on security. So with DevSecOps, it becomes crucial that the same person or the same team is responsible for all of the aspects of the product, right? From how it's built, how it's deployed, how it is secure, all the privacy. So it is essentially properly owning what you build model. And the challenge here is it is very easily said than done, because for the same person to understand uh, all the three aspects, development, operation, and security, is a lot of training and experience requirement. And with the speed at which all the new cloud technologies come up and change, people have to constantly learn and keep an eye. And this is where we are starting to see the limits of a pure human person-based processes. So the need for automated tools, automated build tools, automated testing tools, automated security tools becomes highly essential.
Interesting. So let's talk about some of this automation, right? So people are moving to a model where we have, continued amounts of automation, right? Today we have a lot of, in the customers that I talk to, in the enterprise and the service providers, we see a lot of what I would call like semi-automated build and test. So they'll create a pull request into some versioning system, Git repo, a build gets triggered, but there's still a lot of steps that are manually done, a lot of manual testing still. And then deployments are often handled by like another team who, like a pure ops team, and the way that they do deployments, right? We've seen the gamut, right? We've seen fully automated ones all the way down to it's still you're very traditional. We have a change management meeting, once a month, and then those get approved, manual audits, and applications get kind of pushed out manually, into some of these more kind of progressive modes where we have version controlled infrastructure as code, although this could still be scripts, right? A very imperative type of model, to GitOps, where we now see a declarative model, right? This is really due to the APIs, the open API-ness of Kubernetes and this cloud native infrastructure, tight RBAC. And then today we're starting to see more customers adopt what we call a Git native approach, right? Where not only are you doing GitOps, but the tooling and the infrastructure that you're running on is cloud native, right? And this gives you a lot of benefits from adopting the underside. And so, Prabhu, from your perspective, how do you see security evolving, right? As we start to increase the automation, right? And we remove this kind of manual human element. How do you see that kind of security fitting into these?
I think automated security testing is closely following such a trajectory, and I really like the fact that you have mentioned in today semi-automated build and test, which is quite open and honest actually. Like if you see the market, many people claim that they are a DevOps-based organization, that they have DevOps tools and processes. But then what we find is maybe those DevOps tools and processes are only for the build, and then the test and deployment are still a real person end of the day triggering a pipeline or triggering a ticket on a case management system that then performs the deployment, and things like rollback, for example, are kind of manual. So I kind of agree. And from a security perspective, we need to cater to all of these organizations, no matter where they are in the journey. So if somebody is still performing semi-automated build and deployments, their security requirements are kind of different to what in a mature organization like DevOps or GitOps would need. So as a security vendor, we kind of stay independent of all these models. We try to support a wide range of processes and workflow. And the benefit of Scan being an open model is it naturally fits into multiple workflow styles, and it requires less changes to the workflow to perform security. So that is why we are seeing increased adoption, no matter what level, what maturity level the organization are finding themselves in this broader journey.
Okay. So kind of as we look at kind of some of the kind of best practices for Kubernetes security from like, building software, could you kind of talk about this a little bit?
Yeah, absolutely. So I think I started touching upon the fact that Kubernetes with cloud native, there is a lot of fundamental changes to the way both development, operations, and security are happening. And the whole security requirement can be essentially summarized as the security of the Kubernetes layer and security in the Kubernetes layer. So this becomes like a shared security concern, isn't it? So if you think about, if you step back and think about Kubernetes, so Kubernetes is a wonderful free open source project, right? So we go to the Kubernetes website, we download, we play with Kubernetes, but these are very hello world kind of setup. They often won't have any security. All of the clusters nodes will execute with generous admin level permissions. And to make matters worse, when we try to integrate advanced concepts like Istio service mesh, a native CI/CD pipeline on top of Kubernetes, we are adding more and more insecure bits elements to it, isn't it? So security of the Kubernetes is guaranteeing that the whole Kubernetes, the cloud infrastructure, is quite secure from the start. So it can be achieved in two ways, right? So we use Kubernetes, we follow all of the documentation on Kubernetes website, we go through all of the forums, or we start with a managed Kubernetes platform such as Convoy from D2IQ. We're a big fan of Convoy, by the way. At Shift Left, we have production clusters running on an earlier iteration called Mesosphere. So there is some conflict, some prior art there, but I think it's nice to accept the fact that we are also customers of Mesosphere. So I think when we start with a Kubernetes product, an orchestrator that is built with all these security best practices in mind, then security of the Kubernetes becomes a lot simpler. So there will be, of course, setting up the roles and processes and the elements specific for the organization, but it is a lot simpler than starting from a vanilla Kubernetes from the kubernetes.io website. Then comes the security of all the applications, services, containers, operators that operates within the Kubernetes. And there are a number of ways to achieve this, right? So starting with enforcing best practices, static analysis with the way the Kubernetes applications are built. So enforcing, for example, infrastructure as code model, where anything that gets added, updated, deployed to Kubernetes are declarative in the form of code that can be analyzed both by personals and by automation tools. And then the need for things like build breakers. So the infrastructure deployments are also carried out as part of SCA build process, and the build automatically breaking when there are security vulnerabilities and violation of best practices and policies and so on. So now focusing specifically on the scan product, so we kind of operate on both the space. So scan, we have I think a detailed slide of scan. What scan can essentially do is it can scan both the declarative parts of Kubernetes, which is how the Kubernetes and the cloud native applications are coded as infrastructure, and it can also scan the applications that's going to then operate inside the Kubernetes. So it can identify security issues at the Kubernetes layer, at the application layer itself. So I think this kind of summarizes. So scan is essentially a universal security scanner. So it can operate on all of the aspects of applications, containers, and orchestrators. So it can scan the applications. It can scan the applications for credential leaks, for known security vulnerabilities based on static analysis. It can also look at open source dependencies and identify vulnerabilities in open source dependencies that's being used by the application. And lastly, it can also look at any license violation. And the scan as a product is free, open source, so anybody can go to the GitHub repo and use scan, and the product is purpose built for workflow integration. So we can integrate with IDEs. For example, we have an extension for VS Code. We support a range of CI/CD pipelines, including dispatch product, and I think this is if you look at the DevSecOps workflow. So we start with the code phase, where the source code is developed and tested locally on an IDE, and then we have the build phase, where CI/CD products are involved in building and testing the applications, and then we have the package and deploy phase. So currently with scan, we cover both the code and the build aspect of the DevSecOps workflow. So we can scan applications, infrastructure code, both at the IDE level and at the build level. We can do build breaking logic and so on. And we also have a container scanning product in the works, which will come out in Q3. So this is essentially summarizing our roadmap of what we are thinking at Shift Left. So where we want to produce a single DevSecOps product that works across the workflow. And we already have a very good coverage of programming languages and applications and CI/CD tools.
So if I had a build integration of scan, why would I do it at the code level, right? Couldn't I just have my pipeline scan for me?
Yeah. So when we started Shift Left, we essentially were visualizing that all of the builds will be scanned and secured. So essentially, we built a mission statement called securing every pull request. But what we found was, given an option between scanning the source code at the IDE level and scanning the source code at the CI/CD pipeline level, we found more and more developers performing these scans at the IDE level, because it makes a wonderful case for developers to become secure developers, so they can try out different styles of code, different business logic, and see the security results right there in their IDE itself. And then they then push out a version of code that they are very happy with. And then the pull request becomes essentially a lot easier, because these are code that's already being refined and analyzed by both the developers and the security product. That the whole DevSecOps journey becomes a lot easier. So we see more and more customers opting to do security at the left of the workflow, which is essentially Shift Left. And we are also seeing more and more security needs on the right of the workflow, which is on the packaging and deploy aspect, which is something that's being underserved currently by the industry.
So for the doing it at the code level, would you say this is like a net new use case given that in the beginning you were talking about how traditionally like InfoSec would do scanning or some operations team would do scanning. Would you say that at the code level, a bit built into the IDE, and like what IDEs do you guys support?
So we currently support VS Code, and we have a version working on IntelliJ platform. So yes, it is a brand new use case in a sense. Engineers who never used to perform security scanning, and even ops engineers who never had any option so far, are now able to perform security scan built into their IDE, and it's wonderful. So we support, for example, AWS CloudFormation, Terraform, Kubernetes, and I think I was testing it, even the Convoy dispatch version of Kubernetes, and Scan was able to easily adapt with limited modification. So we are essentially able to security scan for a number of vulnerabilities, number of rules at the IDE level itself, so the person need not deploy an insecure configuration before they start understanding the security implications. So essentially, this is like a new use case, like you pointed out.
Interesting. And so, do you see different vulnerabilities found at the code level versus at the build level?
So currently, we perform more scans at the build level. So what happens is when we try to make the scanning rules, scanning tools consistent, we are essentially punishing the developers by taking over their IDE. So consciously, what we decided to do was to perform just credential and static analysis scanning alone at the IDE level. But at the build level, we then perform all the four scanning, including dependency and license audit. And very soon, we will also do container scanning at the build level. So the kind of the checks kind of expands as we go further right from code build package to deploy.
Interesting. So as we look at like, so as we move towards like a build platform, right? We need some sort of flexible infrastructure to run on, like a pipeline, if you will. And for this discussion, we're going to talk about Day2IQ's dispatch platform. This is our cloud native CI/CD platform, and you know it has both a CI side to be able to do your build, test, integration, and then it has a CD side, right, that handles continuous deployment for progressive deployments. And one of the things that that we actually liked about when we approached Shift Left is your flexible model, right? Especially Scan. It's very simple to be able to integrate Scan into a dispatch pipeline. In particular, we leveraged one of our four front-end languages. The front-end languages are used to configure the pipeline. And so you define a set of actions which have triggers, if you will. Like, am I doing this pipeline based on a ChatOps command like /build or /scan? Am I doing this pipeline based on some label or some sort of a pull request on a specific branch? And so what made it really easy for us to integrate was to be able to create a function, if you will, that calls scan, leveraging Starlark. Starlark is an open source language. It's very much a derivative of Python, compared to, say, Q, which is very similar to JSON. We see a lot of developers, they're already familiar with Python, just in their like day-to-day job. And so for them to pick up Starlark was like a natural fit to them. And so when we kind of collaborated with you to be able to build this integration, you know, we talked to our developers, we talked to your team, and it was very natural for them to be able to build this this function to be able to call a scan on, you know, on every build. In fact, when we build dispatch internally here at Day2IQ, we actually leverage Shift Left Scan. It was very almost trivial for us to be able to integrate it into a, you know, what is a very long pipeline for a very, you know, large pipeline. very simple to do. So that way we're always scanning, because we want to make sure that we don't have any vulnerabilities, that we have compliance audits are successful, right? That our dependencies are clean, and so that was one of the things that that we wanted to ensure, was that it was very easy to do. Plus, we have a lot of developers that are building dispatch in different locations, right? Especially in today's environments, a lot of guys are they work from home. A lot of the women oftentimes need to do development in from their remote homes, and so they need to be able to run dispatch locally, and being able to not have a heavy footprint to do a security scan made it very easy for them, right? Very flexible, so they can do more builds, and therefore do more scans. And it's very kind of a lightweight process, but it provides a significant amount of value that we're seeing. And so I kind of want to go through a little bit of a kind of a demo, I think, on kind of going forward. And I think the demo that we'll do is a very kind of a simple demo, but we'll go through some of the steps. We'll go through some of the functions that we've built, what does scan do. We'll see some of the results, but it's the same. Even though this is a hello world example, this very much reflects a very similar style to kind of how we build dispatch internally, and how our customers would leverage dispatch with shift left. Any thoughts?
Absolutely,
Prabhu?
can't wait for the demo. Yeah, I think we all are eager to see the demo.
All right. So first, we'll just we've got a basic repo here, right? It's just a hello shift left, hello world type of application. It's kind of chock full of vulnerabilities, right? And so it's a good way to catch types of issues. And I'm going to circle back to what our actual pipeline is going to look like. And so we're going to kind of step back, and we're going to look at the pipeline. So the way that the pipeline works is we've got there's a couple different locations where we have code taking place. We have the application repo itself. It's like the hello world repo. It has all the code in it, and it contains this pipeline. And the pipeline is actually fairly short for what it does. So at the bottom here, we have the actions that define what's going to trigger this pipeline, right? We're going to trigger it on any pull request, and then anytime somebody types, let's say /build, right, as a chat ops command. So this would be in GitHub. You would have your pull request. You go into the comments and you type /build. This is a very common scenario. And what it's going to do is it will kick off this task here, this SAST scan task. We have some basic parameters that we're going to pass to it, a token, a set of secrets, where the environment that we're going to do, as well as the repo itself, right? The repo is this resource here. Above it, it's our hello world Git repository that's assigned to this variable here. So this makes it very easy to work with, like in Tecton. I'm sorry, not in Tecton, in Starlark, because we have this variable here that allows us to assign the results of this function. And where Git resource comes from is actually, we're going to load a set of libraries from a combination of both Day2IQ provided open source libraries, as well as your shift left SAST scan. So we're not actually hosting the scanner locally ourselves, which is great, because as shift left updates your scanner with new features and functionality, and updates the dictionary or the libraries that it's using to perform the scans, this gets dynamically built each time, which is a huge advantage for us. And so we have some additional helper functions that we're going to pull in. What is a Git resource? How do I do a pull request? How do I generate a pull request? And then how do I handle secrets? And so this maintains a very simple type of dispatch file. And generally these functions at the top could be maintained by a centralized group, right? For myself to write this dispatch file, I didn't have to write these functions out here. Somebody maybe a centralized team or tech leads have written, that makes it much easier for me. So the way that we would do this, we'll go back to this this repo, and I'm just going to make a quick kind of trivial change, right, just to trigger this. So I'm going to just say this is a shift left demo application, right? We'll just update the README, right? And we'll just create a new branch, right? And pull request, right? And this automatically triggers, and we'll see this. What it's doing right now is this is downloading the dispatch file to dispatch, the cluster itself from the repo. It's also downloading all the source code, and then obviously it's also having to do, based on that, it's going to have to load those functions from those other repos. This takes 30, 45 seconds to be able to do all the downloads, to be able to kind of spin up this environment and begin the automated tests. So we see here that SAST scan is started, and it takes probably a minute or so. We have a fairly small repo obviously for much larger environments, it could take a little bit longer. But Prabhu, what types of scans is it running?
So as we speak, scan is now doing all the 4 scans I mentioned, starting from credential, static analysis, dependency, and license audits. And we typically see times of around 2 to 3 minutes for an average size repo. And the largest we have found for a repo like web code, which is like 500,000 lines of code, is like 10 minutes. So scan is in fact one of the fastest, highly performant product in the market, including even commercial tools. Actually, I think the only commercial product that has outperformed scan is our own shift left commercial product, which I don't want to talk about today. But yeah, scan being free and open source, we have put a lot of thought, a lot of energy into it to make it very very simple yet highly performant.
And the scanner is a container. Do you guys package it as a container?
That's correct. So what we essentially have done is the packaging of scan into a single container image, which is currently supported by a number of CI/CD tools, including Dispatch. So the downloading and updating of the scanners becomes a lot easier. And what we have also essentially done is make it easy to integrate scan by adding all the configuration elements into this container image itself. So the users of scan need not configure scan specifically for their CI/CD pipelines. So we kind of provide that out-of-the-box experience, which our customers love, but it is something that doesn't exist in a typical security product right now, which is unfair. But scan is like very easy to use out of the box. Most of the time, people can just add 1 or 2 lines of code, like how you demonstrated in your dispatch file configuration, to use scan.
So I noticed it failed. What is this like? Why would I mean, do you think this is a dispatch problem? Why do you see potentially this could have failed?
This could be the build breaker logic, or this could be something. Maybe the demo got. It'll be nice to click details and see what's going on.
So what is build breaker logic?
So build breaker logic is essentially automatically breaking the build, failing the build if there are any security vulnerabilities being found. So we provide a default build breaker logic by default that looks at the critical high vulnerabilities across all the scanning tools, and then decides whether the build or the application is ready to be tested, ready to be deployed or not.
Got it. So I know if I click here and I open up my Tekton dashboard, right? So under the covers of Dispatch, right? We are running Tekton. That's the kind of the core engine. However, you're not writing. My pipeline wasn't written in Tekton YAML, right? Tekton YAML is extremely verbose. And so we wrote it in Starlark, and then internally we do some conversion to an intermediary representation, and then from there we convert it into Tecton YAML. But it seems like, okay, let's take a look at some of these logs. Could you kind of walk me through some of what I'm seeing here?
Absolutely. So what to start with, what Scan has done is it has performed a number of analysis on this repo. So to start with, it has identified 3 open source packages that have specific license conditions in them. In this case, these 3 packages have what is called as disclose source. But the most important thing is the same license clause, which is, I think, on the right, you will see. Many organizations, including large organizations like Microsoft, actually find themselves in such tricky situation where they unknowingly use an open source package that has a strong copyleft clause, like same license. This is a real example. So Microsoft, when they tested Scan, they found that one of their open source package, which was licensed under MIT license, used a dependency that was GPL version 3 license. So GPL version 3, I think, as you guys might know, is one of the strongest copyleft license in the market. So what that means is any package that depend on this GPL version 3 should also become GPL version 3, right? And because this Microsoft package was a highly heavily used package, I think Microsoft had essentially single-handedly managed to open source like 1 million applications because of a small flaw with the way they decided their dependency. And then we pointed out to the team at Microsoft, and they were able to negotiate, fortunately, a dual license condition with that developer, so the whole world didn't have to make all of the applications open source. But it goes to show that even a small license audit can have big implications, especially on the enterprise use case. So moving on, so we also scanned the dependencies, and we have identified a number of known CVEs, known vulnerabilities. And the way we prioritize, highlight these dependencies are based on how the packages are being used. And we also do a lot of techniques to fix common errors with dependency vulnerabilities, the way they are rated and so on. And if we continue to move on, I think at the bottom, we will see a summary of the dependency scan result. And in this case, Scan has clearly failed the build because the class file-based analyzer has found a number of critical and high vulnerabilities. So this is build breaker logic properly working, and hence the build has failed. And I think the whole stack, including the dispatch and Tecton, has properly notified the pull request that such a thing has failed. So this is Scan working natively with dispatch with GitHub, isn't it?
Yeah. So it looks like that's what happened. I mean, I would assume that if you found something that was, these critical builds, or critical errors, right, or vulnerabilities, you definitely want to fail it. You don't want to go through what could be a very lengthy pipeline and waste a lot of time and resources when you still have to go back and do these things. Can you configure the scan to continue on, like to not fail the build?
Absolutely. So we do provide command line arguments to carry on, and it's very flexible. So the users can decide how they want to use the scanner. So some teams, they opt to carry on build for feature branches, for dev branches, but then they make it very stricter for release branches and deployment branches and so on. So it is very flexible in that perspective.
Okay. So I guess, like, after you make your changes, you could go back in here, and I think in the actual pipeline, we use /scan. So I'm just going to comment with that, and that should re-kick off the tests, right? Should start up again in in 30 seconds or so. but it makes it pretty easy to be able to, so while this is kind of like kicking off, one thing I noticed was that we're able to, and we see here that this test is, the pipeline is now running. This is the dispatch UI. It's running on Convoy, which is Day2IQ's Kubernetes distribution. So we see that it's running. This is a previous one that we did. And what I can do is I can download the artifacts themselves. So this is all of the, well, let's just look at them, right? I mean, this is kind of what we get, right? Can you kind of walk me through some of what we would see here? Like what some of these
absolutely.
types of files are?
Absolutely. So before explaining these tools, so all of the scanning are essentially performed locally in the CI CD environment itself. So no source code, no secrets ever leaves the build system. So we are not looking at your source code. We are not looking at anything, right? That's the beauty of scan. It is completely private and secure. So this particular HTML view is for use cases where people needs to essentially understand the scan result without having to look at the build logs and understand what's going on. While developers love all of the information in build logs, I think security analysts and product owners kind of prefer HTML. So if you look at, say, class-report.html file, so we kind of make it easy to interpret and understand what was going on. So in this case, we are saying, oh, this is, I think this is dependency scan result you're showing here. So we're saying this particular result has failed. And then we produce a summary where we highlight, oh, the reason dependency scanning failed is because of these critical and high vulnerabilities. And we provide some tips as to how this can be remediated and so on. And we point out all the vulnerable packages, and we provide links to the advisories where this particular code is being discussed with possible remediation advice and so on. So this is a dependency scanner. I think if we look at another HTML file, so yeah, this is, I think, the SAST scan result. So in this case, the summary section is very identical, critical, high vulnerabilities. But what we then do is identify out of the critical defects, the top 4 that needs to be fixed. And what we find is in many cases, the vulnerabilities could be actually managed. We don't have to fix all of the vulnerabilities all of the time. So we have a very basic heuristic to identify top issues that needs remediation. And at the same time, we also highlight all of the findings. Like if you scroll to the bottom of this report, we present all of the findings. And the benefit of this HTML is it is a single page HTML. So
Okay.
customers can download this and they can email it or they can attach it to the ticket. Is that how you guys use internally at D2IQ?
So our developers will look at this, and then they're looking to be able to automate this, right? So be able to like automate creating bug tickets, for example. Do you have content that could potentially like could some of this, like could we leverage like a JSON file or an XML to be able to parse in an automated fashion and then create, in our case, JIRA tickets, right? Because okay, we did this build. Here's a bunch of JIRA tickets that get attached to the project that's being built, or the user story, and now the developer has a set of things that they need to work on in this sprint before we get to somebody signing, a product owner, for example, signing off. So that's how they're starting to. That's how that we use it, right? It definitely makes it easier for us to get that quick view. Okay, what needs to be done at a high level, right? Because product manager, product owners, engineering managers can quickly see, okay, this is how secure the results of these scans, and then the engineers, they're generally, their life is down at they go from like their IDE to their Git repo to the ticketing system, right? That's kind of like their life, right? They kind of stay in that triangle, if you will. But it definitely gives us this flexibility for somebody like myself to say, hey, my project, how secure is this? what are the reports, I can quickly go through it and say, okay, let's keep going, right? This is a feature build or branch. So that
Absolutely.
Makes it much easier. And I mean, looking back, we see, okay, we definitely failed this again, right? This all updated very quickly. In fact, at the same time, I'm being pinged on Slack. So we're a Slack user internally, and our builds actually do Slack integration. So I kind of can see another window that I see a build kicking off. I see that the scan is running, and then the scan failed, right? This pipeline failed, right? And I can come back to here directly from that link and say, okay, let me kind of do some investigation and click on details, see the logs. It makes it, and that would take me to like my to my pipelines that are all my pipelines that could potentially be running. And so that makes it very simple. We get about we get about 15 minutes left. And I just want to, is there anything you want to kind of like close on with regards to SCAN? Here we have your kind of your documentation page, the home page for SCAN.
I think, yeah, so for people new to SCAN, I think the best place is this documentation website where we have captured all the integrations, all the use cases we support, and even the documentation side, along with the SCAN is all open source. So please feel free to contribute. And I think we have a few questions from participants. So there is a question on Istio containerized tool set and how good they are in terms of creating policies. Is it something you want to answer first, Seth?
So I think you'd probably be better to answer this one as it's security specific.
Okay, so yeah, from a security perspective, I think Istio offers a number of security rules, policies, but most often where we find is the human element, the understanding and implementation of these policies. So some organization make a genuine effort to properly configure Istio, but majority is like if it works, then why bother? So that sort of attitude. SCAN doesn't support Istio yet, but we do support Kubernetes configuration. We can go through and analyze statically various Kubernetes pod services, secrets, use of hard-coded credentials, and so on. So if we look at, I think, the secure deployment tab, I think we have captured all of the best practices, all of the rules we perform for Kubernetes and AWS and so on.
All right. So, we have a question here. Are you planning for SCAN to operate in GCP as well?
That's correct. So we already support Google Cloud Build, and we have some specific rules regarding GCP configuration and so on. I think these will be work in progress because GCP also supports deployment manager and CLI and SDK. So there's like various ways of configuring and creating cloud resources. So we currently only support Terraform and handful of YAML-based declarative configurations. And maybe what we can do is we can document the rules. So I think that the Google-related rules are captured under Terraform section right now, but maybe we can create a separate entry and talk about Google-specific scans that we perform.
Okay. There's a question here. The service message space is context dependent at runtime. Think Kiali. How does SCAN complement dynamic security analysis?
That's right. So so we are essentially finding that customers have to use static analysis and dynamic analysis and external endpoint-based scanning. But where we find the shift is dynamic security analysis is very time consuming. In a sense, if you take a single page applications, many remote calls would only get executed when the customer interacts. So they have to log in successfully, or maybe upload a picture, or do some advanced operation for the remote API call to even go out. That a dynamic analysis tool simply cannot capture all of the flows within a small period of time. Whereas this is where static analysis tools can go through every single line of code and look at every single flows and paths. So there are benefits to static analysis based scanning, but in advanced use cases where there is flow of traffic involved across dynamic Kubernetes resources and so on, customers tend to use a dynamic scanning product. So yes, it is a legitimate use case.
So there's another question. So some of our customers are do not have air-gapped environments, right? Their build systems don't have access to the cloud, or to the internet. How could they run scan in that case?
Yeah, so we have one user who is using scan in an air-gapped setup. So what usually happens is there is a need for an internal container registry, which caches the scan container image, and then all the pipelines will be essentially pulling from this internal registry for performing the scan. And the architecture of scan being completely private, everything happening locally, completely suits very secure air-gapped style environment. So yes.
So they could both like clone this function to some on-prem private repo, as well as clone or download the actual container itself, and
Absolutely.
host that internally. Okay.
Absolutely. And then they will prefix the URL with their local version, and they can have a process to periodically pull the updated image, because we constantly add new rules and new scanning features into the product.
All right. And you said that the scanner itself doesn't, like, other than the container itself, there's no need, it doesn't reach out to the internet during the scan. It's purely like self-contained.
Absolutely, yeah.
Okay. Let's see, I think that's all the questions that we have. If there's, there's one other question here. I believe the question was about how can we get a copy of the slides. I believe Arun said that we'd be providing a link to the recording afterwards. And so we could do that, but if there's specific questions you have around code or features itself, please reach out to Prabhu or myself, and we can answer your specific scan or dispatch questions specifically. I'd like to thank you everybody for their time. Prabhu, I'd like to thank you for this this conversation. It's very informative for me. I'm going to turn this back over to Arun.
Absolutely, I loved the conversation as well. Thank you very much, Arun and Seth, for your time, and thank you all for joining us today.
Excellent. Thanks everyone for joining. Thank you for Prabhu and Seth for doing the presentation. And of course, always good to see a demo in live action. As Prabhu and Seth mentioned, please visit those URLs if you want more information. There's Prabhu and Seth's social media handles as well, so you can reach out there as well. And Prabhu has also posted one link in the chat just now, which is office hours for using shift left scan. So those are where you can go in and ask questions to our team if you are having issues running scan. So that is available. And the recording for this webinar would be sent out to all participants. So you can always revisit the topics if you want. Thanks again for your time, and have a great rest of your day. Thank you.